So today, as Siobhan said, I'm going to talk about methane emissions. So what is methane emissions and how can we reduce methane emissions from agriculture, and really learn about some of the role of the feed additives as part of that. So methane emissions, we know that agriculture is responsible for about 37% of Ireland's greenhouse gas emissions. Now, methane is a really important part of the greenhouse gas emissions, and it contributes the most in terms of greenhouse gas emissions, about 60% of our emissions. So sources of methane include enteric fermentation or feed digestion, which is about 56%. And then another source is the stored slurries and manures at about 10%. We are here in Ireland under international and national legislation and commitments to meet our targets. And particularly here in Ireland, we're under the Climate Action and Low Carbon Development Bill. This set out there in November of this year that we must reduce our agri-emissions by about 22 and 30% based on our 2018 figures by 2030. So how is methane emissions produced? So it's produced in the rumen or the belly of the animal, and it's produced during a process of fermentation or during feed digestion. And that process is called methanogenesis. So methane emissions is produced when the feed is ingested by the animal, and bacteria in the rumen then break down the feed, which is a very beneficial process, so we can get the nutrients from the feed. But during that process, because it's an anaerobic environment, we basically, the hydrogen and the carbon dioxide combine to produce methane emissions. This also, this is the CO2 plus the hydrogen combines to make methane and water in the rumen, and that methane is emitted from the animal. This is also a very inefficient process because it takes energy to produce methane. So this results in between a 2 and a 12% loss of feed energy from the animal that could be used otherwise for productive processes. So the big question is, how are we going to reduce methane emissions from agriculture in Ireland? Now, the first way to do this is to follow the advice in the Signpost farms and to use the measures laid out in the Teagasc MAC. And Lillian mentioned it and others today and yesterday. And this is really to improve your management practices and enhance farm efficiency. We're also now developing new technologies because we won't meet our targets with this alone in terms of methane emissions and other greenhouse gases. So we're also working behind the scenes on generating new breeding strategies. So Teagasc are working hand in hand with the Irish Cattle Breeding Federation to try and breed animals with a lower methane output while maintaining all the other productivity in the animals. We're also looking at feeding strategies, and that's what I'm going to talk to you about today. And as part of that, we will hear later about clover and other types of forages, but feed additives are going to play an important role also. But we need to make sure that these feed additives work on Irish farms, and we need to make sure that the claims that the companies make are actually real, and we need more information on how they can be delivered, particularly on pasture-based systems. So that's the research we are doing in a project called Methubate. And this is funded by the Department of Agriculture, Food and the Marines. It started at the end of 2019. And this project sets out to develop novel farm-ready technologies to reduce methane emissions from pasture-based Irish agricultural systems. So within this project, we're looking to mitigate methane emissions. So assessing the feed additive, can it mitigate or lower methane emissions? While at the same time, we're going to monitor its effect on animal productivity. So there's no point in having an effective feed additives if it actually lowers the productivity in sheep and cattle. Some of the feed additives we're going to look at include Bovaer or 3-NOP, as we've heard a lot about in the media. It's one of the most feed additives is further along in terms of its research. Look at seaweeds, oils, halides, supplements like yucca, and of course olive feeds and oils. So a lot of feed additives that are being developed can only be applied in indoor systems because the feed additives needs to be with the feed at all times in order for it to be effective. That's why we need to develop encapsulated forms or slow release options so that these feed additives can be delivered at pasture. And some companies are working to that effect, and including ourselves in the laboratory in Teagasc Grange. We also need to assess the nutritional and the toxicological composition of the meat and milk that's produced from the animals afterwards, because we need to make sure that the products that we produce, meat and milk, have got consumer safety in mind, and that there's no residues. And this is particularly true for things like seaweed, when you hear about bromoform, and iodine, of course. Also, we need to make sure that they're produced sustainably. And this is why these feed additives and the trials that we do will be analysed through the Teagasc life cycle analysis models. And of course, they need to be cost effective. margins are very tight, so they need to be farm level, cost effectiveness needs to be evaluated through the National Farm Survey. So we're looking at a range of feed additives, plant and oil extracts, olive feed products, short-lived reactive oxygen halide species, a range of seaweeds, browns, reds and greens, and seaweed extracts through a project Sea Solutions, as well as our own Methubate project. And we have a lot of companies involved. We have about 8 industry partners in this project, and we're in the process, and we're nearly finished with this, by analysing these feed additives in what we call a RUSI-Tech system, or it's a rumen simulated technique. So it's like bringing the rumen into the laboratory. We're using rumen fluid in that process, and we have fermenters set out where we assess the feed additives. We're also looking at 3-NOP, which is, you hear an awful lot about this feed additive, and this is a chemical where we're looking at, it's a non-toxic compound, and basically we've seen a lot of positive effects of this feed additive in trials across the world, where it's reducing methane emissions by about 30%. This, we know the method of action, it binds to an enzyme in the methanogen species, and we see positive effects of this in vitro and in animal studies. And the productive performance of the animals is not compromised. We're also currently doing a trial on 3-NOP in Teagasc Grange, and we'll hopefully have results from this in the spring. But also there's issues around, we'll have to communicate with our farmers around pasture-based systems and being able to use 3-NOP, a pasture-based system. So they're trying to develop a slow release option for this, and also consumer acceptability. So that means, how can we get around this idea of feeding a chemical in a diet? We need to get this communication around that is actually that there's no residues at the end of it. We're doing a range of animal trials in sheep, in beef, and in dairy cattle, assessing these feed additives using a range of methodologies to measure the methane, including pack chambers, the green feed system, and of course outdoor green feed systems at pasture. We're also looking at early life intervention. So we're interested in the whole concept of altering the rumen microbes, the microbes in the rumen in early life, and these having sustained effects throughout the lifetime of the animal. So we're looking at what is the optimum time frame for manipulation of the rumen. So the first month of life presents a time frame during which the rumen microbiome becomes established. So these methanogens become established in the rumen at this time. So we're looking at, is there lasting effects of the rumen functionality, including the methanogens, that can last into later life? There was a study from France, from INRA, looking at early life administration of 3-NOP to dairy calves from birth to 14 weeks of life, which is a very promising study, where we see reductions in methane emissions which persisted up to 12 months of age. And we're going to repeat this study in Grange next year and try and see if we get similar results in Irish cattle. And this study resulted in a cumulative reduction in around 150 kilograms of CO2 equivalents per head during the first year of life. And just to summarise, methane is a potent agricultural greenhouse gas. We're under national and international commitments to reduce it significantly. We have some promising feed additives that are being assessed using a systematic approach for methane mitigation. And slow release will be a promising application at grazing, and there's potential for early life intervention. So thank you, Siobhan.